Day
to day
17 per
of our
audio
audio
school.
school. This school is to teach you how to do your own install, become a installation technician at a shop, become a shop manager or shop owner at some point. This is my online resume, my body of work that will teach you how to do it yourself. And all of this is for entertainment and educational purposes only. So today we're going to talk about understanding load and compatibility, or basically load management and electrical management. So we'll get right into it. Think of your car's electrical system like the power outlets in your house. It can only be handled by a certain amount of load or demand for electricity at any given time. When you add new electrical devices to your car, like a powerful sound system or extra lights, you increase this electrical load. Understanding load means knowing how much electricity these devices will need to operate safely and effectively. Excuse me. Now, compatibility is all about making sure these new devices can work within your car's existing electrical system without causing any issues. It's like plugging a new appliance into a wall socket. You need to make sure the plug fits and the electrical requirements are compatible. So this kind of goes back to and I haven't talked about it yet, but I'm calling it a one sheet. And what it is it takes into account your battery, your alternator, and what the load is on the vehicle. And then from there, comparing it to what kind of alternator, what kind of amplifier, what kind of speaker, what kind of wires, how thick they need to be, all those things to function within the vehicle that you have without changing the battery or the alternator. Once you start building on that system, then we have to start talking about doing a big three. We'll get to that later. But it involves the alternator and the battery and running thicker gauge. So we create a wider lane for current to flow. Talking about the battery, whether we're going to upgrade the existing battery, add a new battery, or add a capacitor, which is hit or miss. We'll talk about that. And then also upgrading the alternator to supply more power to the system so it doesn't strain the alternator or the battery. So we'll talk about that later because I'm still developing that. In your car, compatibility issues involve several things. So thing number one, power source. Your car's battery and alternator, which recharges the battery while the engine is running, provide the electrical power. So we talked about that. The battery is only to start the engine. The alternator takes over and supplies the electricity, and then the battery then turns into a electrical pool of water, if you will, where the water is stored or the electricity is stored to supply back into the vehicle. If your new device needs more power than your car can supply, it could drain the battery or overload the system. For example, a very powerful audio system requires a significant amount of electrical current, electrical water. You need to ensure that your car's electrical system can handle this extra demand. In hybrid and plug-in hybrid vehicles, HEVs or PHEVs, adding high current electronics can even reduce the vehicle's driving range or fuel economy. Even with that, Depending on the type of Tesla that you buy, some of them have a traditional car battery, and these new ones have a little, almost Power Wheel size battery. And the issue you run into with that is you have a smaller pool of electrical energy or electrical water to cycle through the system back to the battery. Putting an amplifier in there will, in lesser terms, evaporate that water. So that energy disappears because it's being ate up by the amp. And now you lose functions inside the car. And that little battery functions like the car waking up, the key tag unlocking the door, things like that. So you would have to put a bigger battery in there, but it's not that simple. But in the earlier model Teslas, they do have the bigger car battery, so there's a bigger pool of electrical water for the amplifier to draw from, so it's not evaporating that water or using up that energy, and it's not able to be restored by the alternator, which there's no alternator in electrical vehicles, so we have to think about that. Wiring. The wiring in your car, the wires in your car are like electrical pathways. They have a certain size or gauge, like how thick they are, which determines how much current, how much water they can safely carry. If you try to run too much power, too much water through a wire that's too small, you can overheat and potentially cause a fire. When installing new devices, it's crucial to use the correct wire size to handle the electrical load. Sometimes the connectors on the device itself can give you a clue about the intended wire size. So if you look at the back of an amp, there will be 1 to 3 size holes in it. It'll either be a 4 gauge, we can think of it like a pinky. There will be, well, I'm sorry, there will be an 8 gauge, think of it like a pinky. There will be a 4 gauge, think of it like your pointer finger. And then there will be a 0 gauge, think of it like your thumb. And I'll bring some wires up so we can actually see the different gauges. And then I'll also bring some amps for visual representation so you can actually see the holes on the back of the amp where you're going to stick certain size or said size gauge into. The industry standard, like the ANSI, well, I'll give you the whole thing. It's ANSI/CTA/ or dash 2015 R-2017. It's just a graph. It's a graph that shows different gauge sizes and then how many volts or watts that gauge wire can safely carry. So, for example, and this is just a rough example, I'm thinking about like several different things right now, because like a 4 gauge can probably carry, we'll say 100 watts on it, something like that. But then it depends on the type that you have, and I believe it's CCA and copper clad aluminum, and There's another one I can't remember right now, but we will get to it. But it depends on, well, yeah, we'll get to it because it depends on the wire. So there's cheap, inexpensive wire that'll get the job done, but will rust over or corrode at some point in time. Or there's actual copper, and the difference is it's actual copper or compared to CCA, copper clad aluminum, which is aluminum coated in copper, which you don't want that. But yeah, that's just a graph that gives you the different sizes and the different capabilities of power that can run on those gauges. That's all that is. I will show you a graph later. We're at 10 minutes already. Resistance, the electrical resistance is like electrical resistance is like friction in a wire opposing the flow of current. Understanding and managing resistance is important to achieve the desired performance of electrical components. Ohm's law helps in understanding relationships between voltage, current, and resistance. And then there's two more. I don't know if we'll have time, but signal compatibility. In more complex systems like integrating with your car's factory audio system, you will need to consider signal compatibility. For instance, the voltage levels of the signals from the factory head unit might not be suitable for aftermarket amplifier. In such cases, devices like line output converters, we talked about that yesterday, are used to match the signal levels. With digital audio signals, you also need to ensure that the sampling rates and bit depths of the source and the receiving device are compatible. We're definitely going to get to that later in this lecture. Well, not this lecture, but later. And then data networks. Modern vehicles often use data networks like CAN bus to allow different electronic components to communicate. When adding new electronic devices, you need to ensure that they don't interfere with these existing data networks. CAN bus, we'll talk about that later, but basically it will send not pulses, but specific electric signals that are voltages that are meant for said device over I'll say a twisted pair. And twisted pair is just two wires going throughout the system. When we'll say 1.1 volt, I'm just throwing a number out there, gets sent down the signal, that 1.1 volt, only one device will respond to that. And then this is how they can send multiple voltages or multiple signals down this one wire and reduce the overall weight and wire use, well, weight in the vehicle and wire use throughout the vehicle, because you've reduced the amount of wires that you need to complete a given task. And that's pretty much it. I have a bunch of other things I want to give you, but we're already 14 minutes in, and I don't feel like I gave a adequate example or explanation of what this is. So we will end up doing this again, and or you can go to the YouTube. I am Sleepy Digital at YouTube, or Nimbus Electronics and Sound, also on YouTube. And we're going to start giving longer explanations because I got time there. So Thank you, and I'll see you tomorrow.